Okay, so in this exercise, I need to show that the distributive law for the conjunction is true using a truth table. So this is the way that I'll prove it. So let me just write this down. So I have P and Q or R is logically equivalent to P and Q or P and R. Okay, so I have three propositions, so I'm going to have 2 to the 3, so that gives me 8 lines in total. So I'm going to have P, Q, and R, and I'll need to do Q or R, because I do inside the brackets first, and then I'll look at P, so then I'll do P and Q or R. This one I'll do the inside of the brackets. So before I go on to the right hand side, on the left hand side, I've got the column that'll prove the left hand side. And now I'll do P and Q. So inside the brackets, I have this one here. I have P and R. And then the last part is I'll take these two columns and do the disjunction. So I'll have P and Q or P and R. I'll take out my ruler just to keep everything neat and tidy. Okay, so I have my 3 lines, so I'll go with 4 trues first, followed by 4 falses. Okay. In the second column, I'll be alternating between 2s. So 2 trues, 2 falses, 2 trues, 2 falses. And in the last one with R, I alternate between true and false. Okay, so with Q or R, I'm looking at these 2 columns here. So I have true and true. Remember, with the disjunction or the or, I need to have at least one of them to be true. So true, that's true, true. This is false because both of them are false. True, 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 and the last one, false. Okay, so now I'll take this column and I'll do the conjunction, the and. So I'll be looking at this column and this column. And remember, with the conjunction, I need to have both of them to be true. So true and true, that's true. True, true. This is false. I don't have both of them true. Again, false, 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 and false. Okay, now okay, so we've done the left-hand side. P and Q, so true and true, true, true. Again, because I'm using the conjunction or the and, I have to have both of them to be true. So this is false, false, true. Oops. This should be false, 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 false. Now I look at P and R, so I'm using these 2 columns. So this is true, false, true. This is false, and then the rest of them are going to be false because these are all false. So false, 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 false. And with this, I do the or function, so at least one of them has to be true. So this is true, 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 false, 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 false. Okay, so now we look at this column here, and look at this column here. Okay, and they're both the same. since these are the same truth values, therefore P and Q or R is logically equivalent to P and Q or P and R. Okay, and that's the end of the proof.